Hi, everyone. I'm Michael Windsor. Wait, that slides. Next slide. Excellent. I'm Michael Windsor. This is Jarek. We've had the pleasure of working together now for, feels like a year. Feels like about a year. We actually met at PyCon when I was giving a talk about some of our work at Alpha Omega. And so I'll start by introducing Alpha Omega. Alpha Omega is a fund that was co-founded by myself and Michael Scavetta right here, somewhere in 21, 22 timeframe. And our goal was to start turning money into security in open source. And our mission has evolved over the years. It's kind of become refined now. We've learned a lot about the problem. We've managed to raise about $23 million, the majority of it coming from Microsoft, Amazon, and Google, who find it in their long-term best interest that open source be more secure. And so that's been a very productive partnership. There's a problem with the slides? Okay. Great. While you're doing that, I'm going to keep going. Yes. Perfect. Okay. Originally, when we sort of coined the name Alpha Omega, and it was Michael's fault, it was brilliant. Oh, I didn't advance yet. One more time. I'm not advancing anymore. Oh, because you. Okay, great. Alpha represented sort of the 100 most critical open source projects. And Omega was for the long tail, the scale of everything else. As we started working in the space, we realized that, first of all, nobody could agree on what the most critical projects were. Second, the ones that we sort of could agree had lots of eyes and lots of energy and lots of attention on them. There's always work to be done, but we could pour money in there and it wouldn't necessarily make a difference. And we switched our approach and thought about, well, how can we have the most leverage? How can we do things that are highly leveraged activities? And then the Omega is about the scale, where we're doing things that are working to the hundreds of thousands of smaller projects where you can't just go off and influence them directly or have a conversation with them in some way. And so that really has influenced our approach. The next slide talks about that. Really failing on this. I'll give up on that. Great. It influenced our approach a lot in terms of working with foundations, working with package ecosystems. I'm giving a talk in about an hour's time in room 6 where I will go into all the gory details and everything we've learned along the way. So we're doing all these things, and of course XZUtils happens, and we all sort of go, And a lot of interesting things came out of that, that we were like, okay, maybe we're doing things wrong. And one of the things was when we think about supply chain risk, you know, we have these things of like, it's all these different problems. It's like, you know, the size is not really a representation of your risk, right? So XZ is a small little thing, not very sort of obvious attack vector for anything, but turned out to be a very fragile project from a social and ecosystem point of view. You know, and then this just really painful lesson. So open source people love to complain about how corporations bleed them dry. They use their source for free, take it without giving back, yada, yada, yada. Well, guess what? All the open source projects that were dependents of XZUtils were treating XZUtils exactly the same way that they complained about being treated as well. They were treating this source code as if it was coming down from the sky on the back of a unicorn with rainbows coming out of every pore, right? And paying no attention to it whatsoever. And here's the truth. Your software, right, is that shiny sports car on top. And that's how much we're treating the stuff underneath it, right? It's your code, by the way. Every dependency you bring in, it's not their code. It's not someone else's code. It's not someone else's problem. It's your problem. From a compliance, from a security, from a correctness, from your applications, from your business, it's all your problem. So when we were looking at the scaled problem, we tried some various automation techniques to go off and just fix or discover, fix, and push up changes to open source projects to fix them at scale. And it kind of worked, but it was a little frustrating because, you know, the team went off and did some work, and they came back and said, look, we found all these vulnerabilities and we fixed them. And it was like going out to the Pacific garbage patch with a rowboat and coming back with some plastic. And we're like, well, the Pacific garbage patch is probably smaller than it would have been if we hadn't done that. But what can anybody do about that? Can we use that information to be more safe or more secure in any particular way? And the answer was a disastrous no. And so we came across the idea of like narrowing our focus, thinking about what we can do to, instead of trying to pick up the whole garbage patch, which might work eventually, but it's going to take a hell of a long time and nobody will be able to do anything along the way, we shifted our focus thinking about what can we do to clean up one beach at a time. And this is where a partnership began, right? And there are interesting characteristics about a good beach to clean up. It's one where there is a community that cares about the beach. And right now they're not using the beach because it's dirty, or they're using it and they know it's dirty, but they're not super happy about that. And so these are the attributes, right? And by happy coincidence, when I started talking to Jarek, he had all these things. And I started talking about supply chain and upstream and paying attention to dependencies. He's like, oh, I've got a list. I know all of my dependencies. Here's my spreadsheet. I'm like, oh, this is great. I'm like, does your team care about culture? He's like, I'm the head of the committee. We're driving security. It's becoming important. And they knew what they had. Opportunity knocked. And so Alpha Omega funded an audit. Instead of auditing the source code of Airflow, we asked them to go and audit 719 dependencies. Now, not to read all the source code, but to understand how those dependencies represented a risk to them from a supply chain point of view. And so I'm going to hand it off to Jarek, who's done all the actual hard work. I get to just sort of sit around, write checks, and make noise. But this is where interesting things happen. So here you go.
Thanks, Michael. So I'm the Apache Airflow maintainer and committer, PMC member. And let's talk about Airflow security. Who knows Airflow here from people who work here? Not many. So Airflow is basically an orchestration engine, and we have a lot of integrations with a number of other services, external services we talk to. Airflow is pretty huge. If you look at the numbers, those are the numbers from last week. We are working on a new version of Airflow release. It's like we have like 256 active pull requests in 1 week, 62 authors, 129 active issues during that week. It's pretty active project, very active project. We are used by more than 16,000 other projects in GitHub, or they are forking and starring us, and we have more than 3,200 contributors. So we are pretty huge. And this slide you maybe already saw from Munawar's earlier presentation. So this is how Airflow vulnerabilities looked like over time. So this is like from 2015 to 2024. You see, this is the activity. The blue one is the activity that happened on the project, and on the at the top, you'll see that these are the vulnerabilities that were discovered and published in Airflow. And you can see something happened here in 2023, that this kind of flow of those vulnerabilities, or the number of resolved vulnerabilities, suddenly went down. And this is because we've done quite a lot of security improvements. So that just to show you the kind of work that we've already done that. So we've built a dedicated security team. We created and documented detailed process. We introduced the security model. We had some canned response to issues to security reporters so that communication with them can be improved. We disabled some inherently insecure features. We hardened our CI workflows. We've done all the stuff that all good open source projects should do, and also like introduced reproducible build. We have like 15 people in the security team. 5 people are more or less active. We have like 66 committers. That's just in number: 66 committers, 33 PMC members, 3,200 committers. And the thing is, like so we are big enough to attract good stakeholders. We have really good attract attention and funding. So we have very good stakeholders: Amazon, Google, Astronomer, Microsoft. They are all providing Airflow as a service, and they are contributing back to the project. We also attracted funding from Sovereign Tech Fund, and this is the money that funded all the security effort that I discussed before. And as of 2024, we work with Michael. And the thing here, so this is our dependency tree, and if you see, it's like 579. This is kind of just basic security, basic dependency graph without all the external optional dependencies. So we have a lot of those dependencies. Altogether, we have more than 700, as Michael mentioned. So we were a very good candidate because like we can attract funding and attention, and we know that many of our dependencies cannot. And so we looked at how we can work together with like Apache Software Foundation, the PMC members of our Airflow, Python Software Foundation. Michael Larson was involved, who Alpha Omega is funding his position in Python world. And Alpha Omega Fund came in, and we discussed, okay, what we can do to actually know which our dependencies are potentially problematic and what we should do with them. So we didn't want to do the full audit on like, you know, going into looking how many CVEs they have, looking at their code and reviewing that, but basically, we think that we should know our dependencies. Maybe not all of them in person, directly to talk to all the 700 maintainers or teams of maintainers, but for sure to our direct dependencies, we can talk and know who those people are. We know what is their security posture, whether they are secure enough for us, and more importantly, we want to go to them and ask them to help them to improve their security, because our security is pretty, like, it's not good, but like, well, I wouldn't say it's like it's good. It's not like we are secure. We work and we are actively working on our security, but we are only as secure as our dependencies. So eventually we want to review all the dependencies, maybe not directly, maybe transitively through others, but generally we want to know who they are and what they do and whether they are secure or not. We are continuously learning and trying to figure out better ways of doing that. Eventually we want to automate that to scale, and we want to look at when we look at our dependencies, when we talk to them, we want to understand how their security impacts us. It's like not like some vanity metrics that can be assigned to the project, but like, what does it mean for this dependency, for example, can bring a lot of other dependencies to us, and we know that this particular dependency is problematic for us as a project because it brings us a lot more other dependencies that can bring more vulnerabilities. So we look at those dependencies from the perspective of Apache Airflow. And we always remember the people, so we want to talk to people. This is the important part. This is like the most important part, what we've learned, that numbers, and we had a lot of talks here today and the last few days about producing numbers, producing statistics, producing SBOMs, producing information. This is really cool and fantastic as a tool, but eventually we want to make sure not that numbers are right, but the people that we talk to and the maintainers and the projects we talk to, they also understand that there is someone interested in their security that can help them, that can reach out to them, and that they can talk to, and that they care about their security. So what it started with, so from the SBOMs, so we use the SBOMs generated by Cyclone DX of Airflow. We produce them regularly. So we generated the list of kind of prime candidates to talk to. We start small. We started with like 16 dependencies initially. And we produce some automated assessment, and this can later in the future be improved. You know, we heard about all the AI tools, and Michael is and the other Michael, they are exploring different ways how similar numbers can be retrieved more easily. But those are the numbers that tell us not only those are OpenPSF scorecards. Some analysis that I added additionally to that, trying to figure out which dependencies are important to us and which are like important for the industry as well. And from that, this spreadsheet automatically generates also the actions that I can go and talk and propose to those maintainers and those projects in terms of what can be improved in their security. And so those actions here, this is how we generated the initial list of projects we talked to. We had like the emails, we have the contacts. I reached out to the maintainers and the things that I want to talk to them about. And that's how it started. The human component in security bug reporting is important. And that's something that also Munawar mentioned before at the presentation. When they reported issues to our maintainers, to our dependencies, there was very little reaction. And eventually I reached out as a maintainer of Airflow, who is their dependency, their user, it was like the fix in like few days or few hours. There was quick reaction. We received this report from you. We see that your issue, there is a particular vulnerability or particular problem in your code. We got that report, but we ignored it because it looked like an automated report. But when a person like me came to them as a maintainer, they reacted and they did, they actually fixed the problem. So like, this is like a very small font, but the message is like, yeah, we fixed. So experiment was in progress. We have 16 projects. We added security. We proposed them adding security policies, follow up on unsecure workflows, proposed them to implement trusted publishing, following up on unpatched vulnerabilities they have, and proposed some mandatory code reviews. So these are the actions that we started to talk to those projects, that they should do that if they didn't have them. And then we talked to them from the position of other maintainers who are doing the same things. So it's not like somebody random comes to them and say like, fix it. It's just a maintainer of another project comes to them and also says, okay, and I want to help you, and I want to make a PR and submit a PR to you and help you to improve your security, which actually the most important part of the project was to start the conversation between us and our dependencies. So we had different kinds of responses. One is like no response at all, of course, and we will follow up later. It was like happy to get help, or great to get help. I will be happy to get those PRs and help. Another one, I will also a security freak, somebody almost as security freak as I was, and I will involve him later in lots of other things that I do about security. But there was also one case about Chronitor, which I want to talk later before. And now Michael.
Yeah. So when we go to the next slide. One of the really great things that came out of this whole experiment was understanding about both the economics and the social aspects of how to deal with your upstream supply. So let's say you're a corporation and magically is using some software from some open source, unlike every other competitor you have. You're the only ones doing it, and it's just your problem, right? Not so much. In fact, most companies are like, well, I'll let somebody else fix that. We'll just wait for the fix to come up, and it's not our problem until it becomes something we have to deal with. And then you have absolutely no muscle to deal with it. So here's the really hard truth. If you're using some external software, whether it's from a vendor or from an open source supply thing, there's no difference. It's your code, it's your problem, and you have exactly 3 choices. You're either going to be part of fixing the problems, because there's always problems. You're going to fork it and start maintaining your own copy, which, by the way, if you do nothing, you're now maintaining an unsanctioned, unmanaged, and unsupported fork of some upstream thing that you don't understand, right? And that's not a good one. But if you want to fork it to start making patches to yourself so you can say, they're not patching it, we can, that's a great thing. It requires time and energy. Or you can forget it, stop using it, right? That's actually one of the most effective things. Like, stop using this crap. It's not making your life safe. It's making it worse. If you can get rid of it from your supply, great. But that gets harder and harder as the problem child is deeper in your dependency graph. And so you don't have actionability. So your imperative is to start thinking across those dimensions and then actually making those human connections. How many of you are commercial software builders and have commercial vendors that provide pieces of software to you, or a service, something like that? Only one. A few more. Do you have any kind of vendor relationship management? Do you have a contract? You have something in touch with them, right? Now we'll ask the same question. How many of you use open source software? How many of you are in contact with any of your upstream suppliers? A couple, right? Grudgingly, right? You need to change that, right? If you ask your risk management people, should we be okay in not knowing who this vendor is and having no contact to them, they would tell you out of your freaking mind. And yet you're doing exactly that. So this framework has turned out to be really powerful as a way to reason about it. And it's shaping how that organization works and other organizations works. It works for commercial vendors. It works for open source projects. It helps us prioritize work, and we learn a lot along the way. Get to the next slide.
So there are some concrete things that I want to talk about. We had a very interesting case resulting from this. Like, one of the quite known cases, there were Chronitor project, a very small dependency of ours, which but very important because like all our versions of our software depended on that, and maintainer threatened to remove the project because of CRA. So like they said, CRA is coming, I have no time to maintain it, I will not take the risk and I will remove it. And we started discussion, and the whole thing was like, okay, we discussed as a user with them. We started like GitHub issue and discussing in the public issue, and there were a number of people who volunteered to fork it. So it was already like this was like a fork kind of case. And we almost did it, like it was like we almost did the fork, but eventually what happened, the way better, the whole project moved to Palettes Echo, and me and the other maintainer of Airflow became the maintainer of this project because we decided we want to keep it running under the Palettes Echo, which is a small kind of steward, open source steward in the future. And we saved the project. The second one, the second case with a fix. So we had a transitive dependency, which is like Vortex, very difficult for us to handle any security issues there because it's held by other dependencies. And eventually what happened, we discussed what we can do, and we involved all our stakeholders. We discussed, okay, this is something we know we have to fix. And eventually, right now, Google team is working on a security as a security team from Google, from one of our stakeholders is working on patching it, so fixing it for us, patching the old version, so that we can actually use it. So that was also the result of this discussion. The third one was like the forgo. And so we had another dependency which was somewhat connected to Vertex and Flask. It was very difficult to upgrade. We couldn't do it. We tried it and failed. Google's security team also started working on patching it, but that didn't really work. And eventually we switched to a fast API. We just removed the dependency from our tree because we decided, okay, we talked to the maintainers, of course. We tried to figure out how we can work with them, and we decided, no, it's not going to work for us. So this is kind of like, this is the way for us, like just to actively look at our dependencies and all of them eventually and decide what to do with them based on this 3F framework. And long-term targets like full automation and better coverage, and maybe AI will help us with that. We are discussing all things about target all the projects, all the dependencies. We want to make it into a regular incremental process that not only we, but also others can follow by spreading the methodology in findings. And we're talking about that. And maybe contributed to other efforts like PSF can make it into some kind of standard thing, learnings.
So one of the most interesting insights from this was what makes for a good project like this, for us to go and for us to fund something where we spent a remarkably small amount of money and then change the direction of a well-funded project. And what characterizes Airflow is that it is close to revenue for a bunch of businesses. So Amazon, Microsoft, Google, and Astronomer are all able to monetize Airflow as a service. And so for them, putting engineers on that project is very easy to justify. The ROI is clear, and the risk is also very clear. And so by starting this small project, we changed the perspective of the entire Airflow organization and prioritized a set of security fixes. And now they are putting energy upstream. I draw it this way because the tree is hard to represent, but they're going up to their supply chain and working on fixing it. And so where there is money, engineering resources can happen, right? A lot of these smaller projects, you can't give them money. They don't have any more nights and weekends to work on this, or they're not an entity that you could really comfortably give money. So that's one of the key learnings about the economics of this.
Oh, that's you?
It's me. Okay. Yeah. So this is fundamentally a human problem, right? All cross-organizational problems are human first and technical second, right? That is true for vendors. That is true for open source. You have to deal with that, right? The transitive problem is much bigger than we understand. It's exponential, and it doesn't sort of coalesce down to a small number very quickly. Eventually it does, because they all sort of use the same dependencies. But it gets big fast, and that creates risk fast. And there are no small dependencies. You could look at whatever scorecard thing you want. It doesn't matter. Every dependency in your tree has total access to your build environment, exfiltration of your build secrets, because you're all really good at that, and total access to your production environment. What could possibly go wrong, right? And you could say, well, we sandbox things. We do call graph. I'm like, bullshit. You do not. And you know we're good at it, and nobody's close to that, right? It's a science project. So that's it, I think. Yes. Thank you very much for your time. Really, thank you to Jarek and the team at Airflow. What we're able to do with this project has actually transformed our approach to funding security, and we hope it's leaking into other parts of the industry as well. Again, thank you. Thank you all for coming today. We can take questions for a bit. If you have questions about Alpha Omega, just come to my talk at 1 o'clock in room 6. We'll be talking for an hour on tons, 2 o'clock, sorry. 2 o'clock, lots of lessons to discuss there, but happy to take questions for this right now. I'll repeat a question rather than jugging the mic, just say it. Oh, here.
Yeah, thank you so much for the work that you're doing there. I think it's really amazing and a strong sign and signal to the community. Do you have any hard numbers on how much money you have saved Amazon, Microsoft, and Google from this whole project initiative in terms of internal security work they don't have to do anymore now?
That's a good question. I don't have hard numbers, and I don't seek them right now because a lot of our work is sort of anecdotal, to be honest. But I can tell you that from my perspective, in terms of the return on investment for the amount we spent on the audit work, I feel like the amount of energy that is flowing in and will continue to flow is at least 10x, probably more than that overall. I think that measuring security ROI is very tricky because the more you put in, the less obvious the need is for it. You can, it's asymptotic, and so it's very tricky to measure that. Like, we're secure now, so we should stop spending money? Oh, wait, no, we have to keep spending money. It's complicated. Next question.
I have a question. Hey, can you give 1 minute on Temurin, the Temurin case study? Temurin.
Yes.
Which is different than this.
Totally different, yes.
Yes. Can you give 1 minute summary?
So Temurin is, if you think about your supply chain, quick question, how many people here run Java applications? Lots of you, right? Do you use the OpenJDK builds that come for free? You dumbass, stop doing it tomorrow. Right? It literally comes on the tin with, use this under pain of security death. You will do that, don't, right? Do you use the Oracle one? Do you like the licensing terms you get? Would you like one that is perhaps free and secure and tested and has reproducible builds now being reproduced by Red Hat and the Adoptium project at the Eclipse Foundation, right? This is Temurin. So Temurin is a reproducible, secure, TCK tested, and also this other test which provides actual functional and performance testing called Akavit built. It's done as part of the Eclipse Foundation. It's a consortium of engineering companies that work on the project. It is a pillar of supply chain security, not just in terms of reproducibility, but all their practices in their code reviews and their repo configurations and their build environments. They're doing an amazing job. We don't need to give them money to do audits. We actually learn from them more often than not. Was that what you're hoping for me to say? Perfect. Okay. Yep. We've got time for one more question. And I know I'm between all of you and lunch, so.
I don't see any other hands raised. So let's give one more round of applause.